10th CBSE Mathematics, Chapter Quadratic Equations. After watching this video, you will understand to find the roots of the quadratic equation by factorizing. Let us first understand what is a quadratic equation. A quadratic equation is of the form ax square plus bx plus c equal to 0, where a is not equal to 0. In this quadratic equation, a, b and c are numbers. X is a variable. In the quadratic equation, the highest degree is always 2 and the variable is always squared. Now let us look at some equations and try to identify if they are quadratic equations. Let us consider the equation 2y square equal to 6 plus 7y. In this equation, the highest degree is 2. Hence, this is a quadratic equation. But this quadratic equation is not in the standard form of the quadratic equation ax square plus bx plus c equal to 0. So, let us rearrange the terms. We write this equation as 2y square minus 7y minus 6 equal to 0. Now, let us look at this equation x square plus 6x plus 9 equal to 0. In this quadratic equation, the highest degree is 2. It is also in the standard form ax square plus bx plus c equal to 0. So we don't have to rearrange any terms. Let us look at the equation x plus 7 equal to 0. Here the highest degree is 1 and not 2. Hence this is a linear equation. Now let us look at this equation 3m cube plus 5m square plus 7 equal to 0. In this equation, the highest degree is 3 and not 2. Hence, this is not a quadratic equation. Let us now find the roots of the quadratic equation 2x square plus 7x plus 3 equal to 0 by factorizing. Now, let us compare this equation with the standard form of the quadratic equation ax square plus bx plus c equal to 0, where a is equal to 2, b is equal to 7 and c is equal to 3. Now let us see the coefficient of x square, which is 2, and the last term is 3. So we multiply 2 into 3 and get 6. Let us write all the factor pairs of 6, which are 1 into 6 and 2 into 3. Now let us go back to our equation and write the middle term of our equation. The middle term of our equation is equal to plus 7x. Let us also write the product of first and last term. The product of the first and the last term is 3 into 2x square, so it is 6x square. Now we split the middle term and write them as two terms. For this, we have to look at the factor pairs of 6, which we have already found. We have to find one factor pair whose sum will give us plus 7x and whose product will give us 6x square. Now if we look at the factor pairs, we can use 1 into 6 because this can be written as plus x and plus 6x, which will give us plus 7x, and 6x into x will give us 6x square. Now let us go back to our equation. So 2x square plus 7x plus 3 equal to 0. Now let us split the middle term and write them. So we'll have 2x square plus 6x plus x plus 3 equal to 0. Between the first and the second term, we can see that we can take 2x common. So we'll have x plus 3. Between these two terms, 1 is a common term. So we take plus 1 into x plus 3 equal to 0. That means x plus 3 into 2x plus 1 equal to 0. X plus 3 equal to 0 or 2x plus 1 equal to 0. So x is equal to minus 3 or 2x equal to minus 1. So x is equal to minus 1 by 2. So we have two roots, x is equal to -3 or x is equal to -1 by 2 as the roots of the quadratic equation 2x square plus 7x plus 3 equal to 0. Let us take a real life example where the area of a rectangular garden is 30 square feet. The breadth of the garden is 1 feet longer than the length. We have to find the dimensions of the garden. Now, let us assume that the length of the garden is equal to x. If the length is equal to x, then the breadth will be equal to x plus 1 because it's given to us that the breadth is 1 feet longer than the length. Now we also know that the area of the garden is given to us as 30 square feet. Now area of the rectangle is given by length into breadth, so we can write this equation as 30 equal to x into x plus 1. Let us solve this further. 30 equal to x square plus x. This equation is not in the standard form of the equation ax square plus bx plus c equal to 0. So let us rearrange the terms. We have minus x square minus x plus 30 equal to 0. Dividing this equation throughout by -1, we get x square plus x minus 30 equal to 0. Now let us solve this quadratic equation by factorizing. Coefficient of x square here is 1 and the last term is 30. So we multiply 30 into 1, we get 30. We write all the factor pairs of 30, which are 1 into 30, 2 into 15, 3 into 10 and 5 into 6. After this, let us go back to our equation and write the middle term. The middle term for our equation is plus x. Let us also write the product of first and last term. The product of first and last term is equal to minus 30x square. Now we have to split the middle term and write them as two terms. The two terms have to be written from the factor pairs of 30 which we already found. We have to find one factor pair whose sum gives us plus x and product gives us minus 30x square. We can use 5 into 6 because this factor pair can be written as minus 5x plus 6x will give us plus x and 6x into minus 5x will give us minus 30x square. So let us go back to our equation, which is x square plus x minus 30 equal to 0. Let us split the middle term and write it as x square plus 6x minus 5x minus 30 equal to 0. Let us take common terms. We have x into x plus 6 and minus 5 into x plus 6 equal to 0. So x plus 6 into x minus 5 equal to 0. That means x plus 6 equal to 0 or x minus 5 equal to 0, x is equal to minus 6 or x is equal to 5. We have to neglect the negative root as we know that the dimensions of the garden cannot be negative. Let us take the positive root x is equal to 5. That means we have found the length as equal to 5 feet. Now we can also calculate the breadth because breadth is equal to x plus 1, that is 5 plus 1, which is 6. So the breadth of the garden is equal to 6 feet. Hence we have found the dimensions of the garden. In this video we have learned to find the roots of the quadratic equation by factorizing.